At the first stage, the last is scanned, the one that will later need to be fitted to a specific sole. Often, sole manufacturers indicate the last number that corresponds to that particular sole or its group. After scanning the sole, the tread line is drawn. It is located at a certain distance from the edge of the lip, and this distance depends on the height of the last, the type of footwear insulated, demi-season or summer, and along the sole, the profile line of the future last is also drawn. Along the insole line, we determine where the ball of the foot, metatarsal area, is located, and create a plane that, when intersecting with the last, forms a line whose length will indicate the girth width or fullness of the last at a specific point. In parallel, another plane is created. When it intersects the last, it forms a line whose length indicates the instep height of the shoe last. Fullness and instep height for a given size have their own specific values and determine how comfortable the future shoe will be. After scanning, the last is converted into a special format that allows smooth editing and consists of quads, polygons usually made up of 4 vertices. Thanks to these, the surface changes smoothly, remains perfectly smooth, has very few vertices, and participates in precise fitting. For rougher adjustments, control cages are used. They are larger than quads, and one vertex of the cage can affect several polygons at once. Thanks to this effect, cages can be built for very specific tasks. For example, to change only certain parameters, for smoother deformation without sharp angles or creases. Finer adjustments are made using the vertices of the quads. For example, to more accurately fit the tread line, or to precisely adjust the toe edges. All this is possible thanks to parametric geometry and the ability to build a program from a chain of node cells that make up the entire script. In this case, it's used to measure girth and instep lengths, as well as many other functions. This program is called Grasshopper parametric modeling. Thanks to it, you can fully control the entire last modification process without fear of missing anything. You can add edges to the toe and smoothly adjust their sharpness. Today there are many programs for working with shoe lasts. EasyLast, LastMaker, ICad, Romans CAD, etc. One of the most advanced is the Portuguese EasyLast. It has a huge number of last adjustment functions that greatly simplify the work of LastMakers and help create new modifications of base models. But all these programs have limited capabilities and don't always allow you to achieve the desired result. Therefore, new samples are usually created through teamwork, a designer and an experienced LastMaker, who turn sketches into real prototypes based on their knowledge and expertise. Practically any 3D application can be used to create shoe lasts. But there are more convenient programs that remove all the limitations of the ones listed above. And most importantly, they can be fully customized to your own tasks. You simply assemble the necessary functions from blocks nodes, like in a Lego constructor, solving exactly the tasks you need, with complete control over every action. For example, here you can change the toe spring height and simultaneously control the last's girth. The girth itself can also be adjusted, while constantly monitoring the change parameter values, smoothly moving the vertices of the control cage from different sides of the last, until you reach the required value, without breaking the appearance and harmony of the model. Using the control cage, you can almost completely change the appearance of the last, increase or decrease the throat, change the shape of the top crest, adjust heel girth, and perform many other operations. At the same time, you can create sections anywhere on the last. For full control and measurements, change or add crest height for 3D visualization programs. To better detail the appearance of the future model. Another great feature of this method is the ability to change the toe spring. That is, raise or lower the front part of the last, and simultaneously change the sole bend by exactly the same angle to evaluate the appearance of the future shoe. In other words, the sole curvature changes smoothly by exactly the same amount as the last. It's also worth mentioning the possibility of applying an offset to the last surface. In simple terms, adding material thickness, the thickness of the upper leather, lining leather, or fur depending on the seasonality of the shoe, as well as the insole thickness or an orthopedic insole if used. All this for evaluating the overall appearance and final fitting to the sole, taking these features into account. Taking the insole thickness into account, the orientation of the shoe last relative to the sole tread is changed to assess how much the future shoe will be raised above the edge of the sole lip. And we must also mention one amazing technique that allows the final fitting of the last to the sole, a method I haven't seen in any of the programs I've studied. In this video, the red last is the last with added material thickness. In this case, I'm using 3 mm. By smoothly moving the cage vertices, I bring the red last exactly to the edge of the sole, and as the red surface moves, the original green last surface moves with it simultaneously. After the last is completely formed, it is prepared for milling and sent to the CNC-last making machine to produce a finished product, a full-fledged shoe last, or a trial block for preliminary checking of how the finished shoe sits on the sole.